Welcome back to my AI-powered mapping series. In today's video, we're combining Esri's static basemap tile service with OpenAI to create an interactive tile puzzle game. I'm going to walk you through how to take a location description like Eiffel Tower or where the 49ers football team play and turn it into a fun geospatial puzzle that you can solve. So let's get started. All right. So we're going to start with our basic HTML structure for the puzzle game. So first we need an input field where the user can enter a description of the location that they want to see in the puzzle. This input field will allow us to take user input and use it to generate the puzzle. Now below the input field, we'll add two buttons, one for generating the puzzle and another for showing the solution. Next, we will need to add a container for the puzzle and the solution. We'll display the puzzle in a grid format and hide it initially. The solution will also be hidden until the user clicks the Show Solution button. Now we'll also use two divs, one for the puzzle and one for the solution. Lastly, we'll need a place to display the location address, which will update dynamically based on the user's input. All right, next I'm going to add some CSS for styling and structure. And now we'll go ahead and move on to the JavaScript. First, we will define our token for accessing Esri's static basemap tile service. We'll also need to set the zoom level, or Z level, the number of rows and columns for the puzzle, and the total number of pieces that will make up the puzzle. Next, we get references to some of the important elements on the page using document.getElementById. All right, so next we're going to initialize two arrays, pieces and selected pieces. And the pieces array will store the individual puzzle pieces, whereas the selected pieces array will keep track of which pieces the user has selected when swapping them. All right, next we're going to create the lat_lon_to_tile chords function. And in this, we'll take the latitude and longitude, we'll apply some mathematical formulas to convert those geographic coordinates into tile coordinates at a specific zoom level, and then return an object containing the tile's X and Y coordinates along with the zoom level. Next, we're going to create the fetchTileImage function, which will actually fetch the map tiles from the Esri's static basemap tile service. And so this function is going to take in the zoom level, Z, the X and Y coordinates of the tile, and it uses the token that we defined earlier for authentication. So it sends a request to Esri service, and it retrieves the tile as a blob. And then it'll convert it into a URL that can be used as the background image for our puzzle pieces. Next, we'll create the createPuzzlePieces function. And this is going to first convert the user's latitude and longitude into the correct tile coordinates, then loops through all the puzzle pieces, creating each one, and sets their background image to the corresponding tile. Inside this function, we'll use fetchTileImage to fetch the images for each tile, set the background image of each piece, and add it to the puzzle board. We also add a click event listener to each piece so that the user can interact with it. Now once all of the pieces are created, the pieces are shuffled to mix them up. So next we're going to create the shufflePieces function. And of course this will shuffle the pieces together. And we're going to do this by randomly swapping the background images of the pieces. So after shuffling, we can add the pieces to the puzzle board and allow the user to start solving. Next, we'll create the createSolution function. So similar to how we created the puzzle pieces, this function fetches the images for each tile and arranges them in the correct order, placing them on the solution board. So we use the same method of calculating tile coordinates to retrieve the right tiles and set the background images. Now we have the solution board set up, but we also need a way to handle clicks on the puzzle pieces and allow users to swap them. So this will be done with handlePieceClick function. And this is going to allow users to select pieces and highlight them when clicked. If two pieces are selected, the swapPieces function is going to be called to swap their positions. Now next we're going to create the getAIRefinedLocation function. And this function sends a request to OpenAI's API to refine the location description provided by the user. Now this response is processed to return a more accurate and usable location description that can be used with the geocoding API. Next, we're going to create the getLocation from description function, which will take the refined location description and it will query the ArcGIS Geocoding API and return the coordinates of the location. If a valid location is found, it will return the latitude, longitude, and address. And finally, we're going to trigger the puzzle creation when the Generate Puzzle button is clicked. And this is handled by the Generate Puzzle event listener. It will fetch the location from the description, create the puzzle pieces, and display the puzzle. So we will also have a button to show the solution, which will be triggered by the Show Solution event listener. It simply displays the solution board when clicked. All right, now let's go ahead and test out this application. So first, I'm going to enter a location description like the home of the first human flight. Then I'll hit the Generate Puzzle button, and as you can see, the system generates a 3x3 tile puzzle based on a map of Kill Devil Hills, North Carolina, where the Wright brothers made their historic first flight. Now the tiles are shuffled, and your job is to rearrange them to match the correct map layout. So to solve the puzzle, you can simply click on any two pieces, and they will swap places. So keep swapping until you've got the puzzle together. And if you get stuck or just want to skip ahead, you can see the solution by clicking the Show Solution button. All right, let's try one more. So I'll enter where the world's most famous cherry blossoms bloom every spring. And I'll click the Generate Puzzle button. We see that is in Washington, D.C., where those beautiful cherry blossoms transform the city every year. And the puzzle will adjust to the new location as expected. And that's it. And that wraps up today's AI-powered tile puzzle tutorial. We've seen how to integrate Esri's static basemap tile service and OpenAI to create a dynamic puzzle experience from location descriptions. I hope you enjoyed this app, and if so, be sure to come back tomorrow for another AI and mapping sample. And as always, happy coding!